Hi guys, rate of change is an important concept in calculus. It is in two forms. First one is the average rate of change and the second one is the instantaneous rate of change, and I will start with the first one, which is also known as the average velocity over an interval AB. So suppose that we have an object that moves along a straight line according to an equation of motion y equals f of x, and here x is the time and y is the displacement of the object from the origin at time x. So say you start your journey at this point at time equals 0, and then 8 seconds later you are here at this point, right? So this is your position at time x equals a, and this is your displacement at x equals a, and then you start walking from this point to this point, and after b seconds later you are here. So that means that your displacement is determined by f of b, so this distance is f of b. And what is the total displacement while you move from this point to that point? It will be f of b minus f of a, right? So similarly, if you throw a pumpkin up in the air, so at time x equals a, this is going to be the height of the pumpkin, and time x equals b, that's going to be the height of the pumpkin, right? And the total displacement from this point to this point will be f of b minus f of a again. Okay, so the function f that describes a motion is called the position function of the object, and we can now talk about the average velocity formula. What is the average velocity over the time interval AB? That one is the total displacement over total time spent, so it will be f of b minus f of a divided by b minus a, right? So one more time, average velocity over AB is also known as the average rate of change of f over AB. So in questions you might see one or the other. Don't get confused, they're asking the same thing. So if I ask you what this quotient is, you will tell me that this is going to be the average velocity over the interval 1, 3, right? Between 1 and 3. And this next one here, your interval is shorter than this, right? But it computes still an average velocity over that interval. Okay, let's see our first example. We are going to compute the displacement of a particle moving in a straight line given by f of x equals 1/2 x squared minus 6x plus 23, where x is measured in seconds. I'm going to first find the average velocity of the particle over 8, 10 in that interval. 8 to 10, and then secondly we will find the average rate of change of f over 6 to 8. So first thing first, average velocity over 8 to 10 over that interval. So a is 8, b is 10. So if you compute f of 10 minus f of 8 divided by 10 minus 8, this will do the job for part A. And f of 10 is beautiful because you use this function, right? 1/2 x squared minus 6x plus 23. So if you compute the output value, it will be 13, and f of 8 will be 8. F of 8 will be 7. So double check these values and let me know if I'm wrong. So f of 10, 13, minus f of 8, 7, divided by 2 is a beautiful 3. So what is your average velocity over the interval? 3 feet per second, and make sure you include the unit in your answer at the end. Alright, secondly, average rate of change over a different interval, 6 to 8. And f of 8 minus f of 6 divided by 8 minus 6 is the quotient you need to find to answer this problem. So that will be 7 minus 5. Double check that f of 6 is 5. One more time, f of 6, just you plug in 6 for x here, right? 1/2 6 squared minus 6 times 6 plus 23. That's a beautiful 5. So the answer will be 2 over 2, 1. So the average rate of change of your function on that interval will be 1. All right, so that finishes our discussion about the average rate of change, but in the next video I will show you another problem that will lead us to the instantaneous rate of change. Thank you for your attention.